So when we're working with a Cartesian plane, we need to know that sine theta is equal to y over r, cos theta is equal to x over r, and tan theta is equal to y over x. Okay, so that's really important. So let's look at this question. We see that in the diagram, line OP is given with P, -3, and -4 being x, -3 being our x value, and -4 being our y value, and they tell us the angle, they're showing us the angle A. Okay, so let's start off with 5.1.1. We want cos A. So first of all, we know that we have our y is equal to -4, so that's basically 4 units. We know that we have our x, which is -3, so the units, that's 3 units. The coordinate is -3 and -4, but in terms of the size of that side, it's 4 units, and the size of that side is 3 units. Okay, so let us move on. So we are asked to find cos A. Now, cos A, as we see here, is x over r. So in order for us to get r, we need to work it out. And we can do that using theorem of Pythagoras. Since this triangle becomes a right angle triangle, we can use theorem of Pythagoras. And we can say that OP, or in this case will be r squared is equal to 4 squared plus 3 squared. And that's theorem of Pythagoras. The reason why we add them up here is because we are finding the hypotenuse. If we are finding either of the other two sides, we'll subtract it from the hypotenuse. Okay, so then we can just say r is equal to the square root of this, and that will be 16 plus 9, 25, and therefore r will equal to 5. So now we know we have our x. This is our x, we have our y, and now we have our r. So therefore, when we say now cos A is equal to x over r, which is equal to -3, okay, not -5, sorry, -3 over 5. Okay, and we're done with that too. So similar to the last question, but here we have cos 2a, and we need to basically use one of our double angle expansions to open this up. I'm going to choose to use cos 2a is equal to 2 cos squared a minus 1. And it's really simple. We worked out cos A in the previous question was -3 over 5. So it's going to say 2 into -3 over 5 squared minus 1. And when we square what's on the inside there, we're going to be left with 9 over 25 minus 1. And when we multiply here, we have 18 over 25 minus 1. And that's going to be -7 over 25. Okay, so importantly, they say without using a calculator, what that actually means is they don't want you to put the entire thing into a calculator and get the final answer. If you need assistance here to work this out using the calculator, that's perfectly fine. But just make sure you're not going from the question directly to the answer. That's what they mean by not using a calculator. But if you want to do this manually, what you would have to do here is say 18 over 25 minus 25 over 25, and we will left with -7 over 25. Okay, I hope that helps. 5.1.3, and we have sine A minus B. Now we're going to use our compound angle expansion here, and then we know that, first of all, we're going to have sine A cos B minus cos A sine B. Now let's look at the question one more time. We see if it is further given that sine B is equal to 4 over 5 and B is within 90, is from 90 degrees, greater than 90 degrees, but less than 360. So basically what they're telling us here is that they're telling us that this angle is found in one of those 3 quadrants. So it's not found in any of the other quadrants, it's found in one of those 3 quadrants. Okay? And how do we know which quadrant it's actually found in? There's the key here. Okay, it says sine B is equal to 4 over 5. And we can see that it's not in the first quadrant. So we ask ourselves, where else is sine positive? When we look at our cast diagram, sine is positive here in the second quadrant. So now we understand that this is found in the second quadrant. So let's just draw this very quickly. So it's found somewhere here, right? And we know that sine B is actually y over r. So this would be our y value. This would be our r value. Okay, so this is where the point will be found. Okay, we know that it will have a y coordinate of 4. We aren't aware of the x coordinate just yet, but we know that this is 5. The hypotenuse is 5, but the r value is 5. So now what we need to do is basically substitute our values. Okay, let's get back to the black pen. So we have sine A. How do we calculate what sine A? We already have all the values in terms of angle A. So this here is now what we drew now is angle B. Okay, so when we use theorem of Pythagoras here, we're going to find again that x here is negative 3. You can work that out. Okay, so let's look at sine A. Sine A will be y over r in terms of A. So y will be minus 4 over 5. So minus 4 over 5. Let's do the same for cos B. Cos B will be x over r, negative 3 over 5. And then for cos A, we now have, let's go back to the A, and cos x over r will be negative 3 over 5. And then sine B, we go to the B, and when we find that it's y over r, so negative, it'll be, sorry, positive 4 over 5. Okay, so now we're going to multiply this out. Here we'll have a positive 12 over 25, and here we will have plus 12 over 25 again. Negative times a positive will give us a positive 3 here, times 4 will give us 12, 5 times 12 equals 25, and we're left with 24 over 25. We have a common denominator, so we can just add the numerators.